Hey folks, in this video we're talking about protons, neutrons, and electrons, or protons, electrons, and neutrons. This is the basics of atoms. Let's get going. So we have a few objectives here. I want y'all to be able to, by the end of this video, identify the different parts of an atom, compare and contrast these subatomic particles, which make up an atom, identify the charge of the atom, and look at a puppy. And there's a few other small things in there as well. We're going to have some new vocab up in here. Check it out. We're going to be using these words and identifying what they are throughout this video. So let's get rolling. All right, so starting off, subatomic particles. 1. There are 3 subatomic particles that make up the atom. And these are the proton, the electron, and the neutron. And we abbreviate them all with cool little symbols. P for proton with a plus, E with a minus for electron, and N with a little 0 for the neutron. And we'll see why they have these specific things and why it just isn't PEN in a little bit. And there's actually a whole bunch more subatomic particles than just these 3, but we're not really going to worry about them in this video. That's more some particle physics stuff, which is super rad, but not for this video. So our different subatomic particles, they have different masses and different sizes, and that's going to be important, as we'll see later on. So the mass of these dudes, when we talk about the mass of a subatomic particle, we're usually going to refer to that in atomic mass units, very convenient, or AMUs, a moose, kind of like an emu. And so protons and neutrons, they have about the same mass, approximately, and that's roughly 1 AMU. Neutrons turn out to be a little bit heavier. And so electrons, by comparison, have about 1/2000th of that mass. They're so light that they kind of don't matter. And when we're talking about what the mass of an atom is, how much an atom will weigh, if you will, we don't really consider electrons because they're so teensy tiny. We only are focused on the protons and neutrons. And if we're talking about the size of these particles or their volume, the same thing is true. Protons and neutrons are big by comparison and about the same size, while electrons are teensy. So our protons and neutrons, big suckers. Our electrons are teensy by comparison. Cool. So these particles have different things called charges. Charge, kind of like a battery, has a positive side and a negative side. That's how we describe charge in subatomic particles. And so we're always going to have a number value to go with charge. So something might have a +1 charge, or it might have a -2 charge. But they're always going to have whole numbers, values. So plus or minus whole numbers. Protons have a +1 charge. If you recall, protons are a little p with a plus sign on it. The plus is for that positive charge. Electrons, a little e with a minus sign, well, that's because electrons have a -1 charge. And neutrons have no charge, which is why the symbol for a neutron is N with a little 0 on it, because there's no charge there. And so if we're talking about an atom, the charge of an atom is going to be equal to the number of protons we have minus the number of electrons. And so most atoms are going to be neutral. Most atoms, or when we talk about specifically atoms, we'll generally assume that they have no charge or are neutral. If an atom does have a charge, if it has either more protons than electrons or more electrons than protons, an imbalance, it will have charge, and we will call it an ion. And we'll do a little bit more with that later. So here's the nice little table summarizing all of that information. We have the symbols for each one of our dudes, we have their charges, and we have their relative mass in AMUs. And so we can see these guys are about the same, and electrons are very small by comparison. Nifty. So let's do a little bit of practice with calculating charges. We're going to remember that charge is equal to the number of protons minus the number of electrons. And why don't you pause the video here and see if you can determine the charge for each one of these setups. Go ahead and pause the video and yeah, try that out now. Great, so you gave that a try and you paused the video. Let's run through these together. Well, the first 3 are very easy. If I have 1 proton, then I'm just going to plug that in. 1 minus 0, no electrons, that's going to give me +1. If I have 2 protons and no electrons, well, that's going to be 2 minus 0, +2. If I have 3 electrons and no protons, well, I'm plugging 0 here and 3 for my number of electrons. That's going to be 0 minus 3 or a -3 charge. If I have the same number of protons and electrons, I would do 5 minus 5. That's going to give me 0. Here, I'm going to ignore my neutrons because they're not part of the calculating charge. So I'll do 6 protons minus 5 electrons. That's going to give me +1. I'll do 22 protons minus 25 electrons for that one and ignore the neutrons. So my charge here will be, that's right, -3. And for this last one, what do you think the charge is? That's right. The charge is going to be +2. Because it'll be 75 minus 73 for a +2. Nifty. So I hope you feel like you're pretty good at calculating charge. Let's move on and talk about some other stuff. So where are the different subatomic particles found? An atom is made up in a very ordered fashion, and it turns out the protons and neutrons like to hang out together. They have the same size, the same mass, and they like to hang out together. And they're going to be found in the center of an atom. If an atom is a big old thing, the very center is the nucleus where the protons and neutrons are found. This is similar to the nucleus in biology, which is generally somewhere in the middle of a cell. So the nucleus doesn't really move around very much. These protons and neutrons kind of stay clustered together, and they just kind of vibrate a little bit. But they don't move beyond that. In contrast, electrons surround that little nucleus in the middle. And they are constantly moving all over the place. In fact, the movement of electrons is very interesting stuff for chemists to study. And so here is a crappy image. This is what we call a Bohr model, which is discussed in other videos. But this shows our neutrons and protons hanging out in the center in the nucleus, and then around that, moving about our electrons. Now, this next image is a more accurate representation of the size of an atom. If we imagine that the nucleus is a pea in the size, it's the size of a pea, and is in the center of a football field, then the electrons would basically be the size of a tiny speck of dust, and they would be found outside of the football stadium, just to give you an idea of how much space is actually in between these things, and that most of an atom is empty space, and just these little particles zipping around with not much around them. Oh, look at this cute dog. Thank you, cute puppy. No, you can't have any money. Get out of here. So subatomic particles, moving on. The number of particles that we have is very important. So as we look at our protons, neutrons, and electrons, the amount or number of each tells us a lot. The number of protons determines what element we have. So protons can be thought of as the most important subatomic particle, or at least I think of them that way. And so, for example, hydrogen is an element that always has one proton. If you have an atom and it has one proton, then it is hydrogen. That's how it works. So protons determines what element we actually have. And so our atomic number is the number of protons and also the number on the periodic table. So if we look at a periodic table and we look at element number 11, well, that's going to tell us that it is sodium and that every sodium atom has 11 protons. Very cool, very useful. I don't know about very cool, but definitely very useful for understanding the periodic table. Another thing that we already talked about is the number of protons and electrons determines the charge. As we said, an atom with unequal numbers of protons and electrons is going to be charged, and we're going to call these charged atoms ions. And so what we haven't talked about yet is the number of protons and neutrons. These together determine the atomic mass, and we've sort of alluded to that electrons don't really matter when we're talking about the mass. But atomic mass is the mass of an atom measured in AMUs, and that's going to be equal to the number of protons plus the number of neutrons. Atomic mass is also very important for chemists in doing calculations. And so something else we're going to talk about later is how neutrons determines what isotope you were looking at. Isotope, some fun vocab for another time. Nifty. Well, let's do a little bit of practice here with this table, and I'll walk through how we fill this in. But basically, for each row, we can fill in the blank boxes. So for this first one, I know my atomic number is 6 and my element symbol is C. Well, I can look at a periodic table at atomic number 6 and see that that is carbon. And let's see, what else don't I know? Well, protons. How many protons do I have? Well, if the atomic number is 6, I know that I have 6 protons. Well, electrons, how can I figure this out? Well, if I know the number of protons and I know the charge, if my charge is 0 and I have 6 protons, well, I can plug this in here and say 0 equals 6 minus 6. 6 minus 6 electrons is going to give me no charge. And if I want to figure out the number of neutrons, I can do a similar thing with the atomic mass formula here. I can say, all right, 13 is the atomic mass. I know I have 6 protons, so 6 plus what number gives me 13? 7. Zippity-doo-dah. Let's go through the next one together, and then you can try the last 3 yourself. So helium. All right, helium. I can find this on the periodic table, or if you're not super mastered at the periodic table, you can just Google it. But helium has the symbol He, and we can use these things to figure out that it is atomic number 2 on the periodic table. Well, we can't do the atomic mass yet because I don't have the number of protons, and I can't do the charge yet because I have the number of protons, but I know the number of protons should be 2 because atomic number of protons are the same. Neat. And so now I can figure out, okay, atomic mass is going to be protons plus neutrons, so that should be 4. And charge is going to be protons minus electrons, so 2 minus 2 should be 0. Sweet. Why don't you pause the video and try filling out the next 3 yourself, and we'll go through them together. Cool, you paused the video. Let's go through these together. Well, if I have atomic number 12, I know that that's my dude magnesium, symbol Mg. If my atomic, let's get our number of protons first. If atomic number is 12, I must have 12 protons. Well, if I have 12 protons and my, let's do charge next. If I've got 12 protons and 10 electrons, 12 minus 10 is going to give me plus 2. And my number of neutrons, well, 26 is going to be equal to the protons plus our neutrons. 12 plus 14 will give me 26. And so for our next row, let's see, I don't have any of this stuff, but I know the atomic number is the same as protons. So that tells me atomic number is 15. That lets me fill in the symbol and the name of the guy. And if I know I have 15 protons and 16 neutrons, it gives me 31 when I add those together. And if I know my charge is minus 3, well, that means I must have minus 3 equals 15 minus the number of electrons. 15 minus 18 is going to give me a minus 3. And I can do for the next one, iron is Fe, and that's atomic number 26. It's not over yet. And then if my atomic number is 26, so that's my protons equals 26. If my atomic mass is 56 and I know there's 26 protons, I must have 30 neutrons to give me that total number of 56, 26 plus 30 to give the atomic mass. And I know my charge now, if I have 26 protons and 26 electrons, 26 minus 26 gives me 0. Sweet, that's the end of this table. That's the end of this video. I hope you feel like you understand the subatomic particles and how they are useful in understanding properties of atoms. And I hope you have a great rest of your life. Ta-ta!